The heart obviously influences blood pressure by generating systole, right? That cardiac output, the stroke volume, the force or contractility with which it contracts. And the vessels, they contribute to blood pressure through resistance. There are other physical factors affecting blood pressure, and they include the cardiac output, peripheral resistance, viscosity, turbulence, and blood volume. Right? Blood volume actually varies, which changes all of the other variables there. For example, when it increases when you are bloated, and it decreases when you're dehydrated, both of which affect blood pressure and affect all of those other variables. It's hard to think of blood pressure in a vacuum, which is really what we're doing. But the most important mechanisms to regulate your peripheral resistance and blood volume is the heart, blood vessels that are driven by neural inputs, and the kidneys. Short-term neural control. It all functions altering peripheral blood pressure and consequently cardiac output. Short-term neurocontrol is the brain's attempt to overrun the kidney and say, I need to ensure that MAP, the mean arterial pressure, is adequate. And your neural system will adjust blood vessel diameter in order to maintain MAP. These adjustments occur in seconds. It's constantly moving like trying to hit a moving target. In addition, this can redirect blood flow based on the demand of organs, right? So while you work out, blood flow to your digestive system decreases and it increases to your skeletal muscles. These changes are regulated by the vasomotor center that's located in the medulla oblongata of the brain. It's the medulla oblongata that is taking in chemoreceptor and baroreceptor information and making slight, small adjustments in vessel diameter. The heart influences blood pressure by generating systole, and the vessels, they contribute by giving resistance, right? There's other physical factors, but short-term mechanisms also receive hormonal control. Many hormones, lots that we'll talk more with the kidney, are involved in blood pressure regulation. Norepinephrine and epinephrine, antidiuretic hormone, angiotensin 2, erythropoietin, natriuretic peptides, many things that we have talked about in the endocrine system. Norepinephrine and epinephrine, they predominate during periods of stress, right? And those hormones enhance your sympathetic fight or flight response, right? In stressful short-term situations, like finding out that you did not prepare properly for your biology test. That will, right, cause epinephrine and it will squeeze all of your vessels and cause your blood pressure to increase. The antidiuretic hormone, or ADH, stimulates water conservation at the kidneys, right? So in cases where your blood pressure falls dangerously low, like when you cut yourself very badly, ADH is released to increase pressure by causing dramatic vasoconstrictions in your peripheral arterioles. Erythropoietin is a hormone secreted by the kidneys, and we know that erythropoietin causes an increase in red blood cell production. So erythropoietin increases your CRIT. And this leads to increased blood viscosity, right? If your blood is more viscous, more resistant to flow, then your blood pressure is going to increase. Atrial natriuretic peptides, they actually cause blood volume and blood pressure to decrease. They're one of the very few hormones that doesn't make things worse. And what they do is ANPs, they block renin and angiotensin. Right? By blocking renin and angiotensin, they cause the kidneys to excrete more sodium and more water, deflating you as a water balloon and decreasing your blood colloid osmotic pressure, right? But right, this lowers the blood volume and it causes the blood pressure to drop. The kidneys are the master control of blood pressure. They're kind of like a bottleneck. Um, there's little tiny capillaries in the kidney, and it's almost like the blood gets there immediately. It's like a traffic jam. So the kidney receives about 25% of your cardiac output. Blood comes out of the aorta, and 25% of it goes right into the kidney. So it really does make the arterioles of the kidney the master control. They also determine long-term control. So they can make adjustments very quickly, but your kidney is more about remembering what has happened to you over a long period of time in order to express its regulation. So to maintain a constant blood volume, that's really what the kidneys focus on. And they keep the average blood volume at about 5 liters. It can vary a little bit depending on age, size, gender. Kidneys can act directly or indirectly. But either way, what they're looking to do is stabilize the mean arterial pressure. Direct action from the kidneys involves increasing the filtration rate. So let's say that blood volume goes up, blood pressure goes up, and the kidneys are like, ah! And what they do is they increase the filtration rate, which makes more urine. And then you pee out that urine, and that's kind of like decreasing the water that's in the water balloon. So blood volume goes down and blood pressure goes down. The kidney can also work indirectly to stabilize the mean arterial pressure, and it does that more through its hormones, such as angiotensin 2. Angiotensin 2, you would think that it's bad for humans because all it does is increase your blood pressure. So angiotensin 2 causes systemic wide vasoconstriction, like everything, vasoconstriction. It also turns on ADH, increasing blood volume, and it turns on aldosterone, which makes you keep sodium and it raises your blood colloid osmotic pressure. So here is this hormone that the kidney likes to use that doesn't have an opposing hormone to it. And this hormone works on all of your blood vessels to do vasoconstriction. And we know that that causes resistance to blood flow, increases blood pressure. It causes aldosterone to turn on, which increases your blood colloid osmotic pressure, which we know that decreases your blood flow, increases your blood pressure. And then it also fiddles with your whole blood volume by turning on ADH. It just puts more water in the balloon, turning on ADH, making you thirsty, and then putting more pressure in you, the balloon. So it seems that this hormone would be wrong for humans, but it actually, it's more, let's say you have less leeway to have a low blood pressure than you do to have a high blood pressure. So there are all of these mechanisms to bring it up. This is also why an ACE inhibitor is one of the first blood pressure medications that people are prescribed. An ACE inhibitor stops the enzyme from making angiotensin. And so an ACE inhibitor, no matter what the cause of your blood pressure is, will most likely provide you with the solution if you can tolerate it.